Welcome to Flipped Classroom. The subject today is algebra, and we are looking at the distributive law, or expanding brackets. Our learning intention for this lesson is we are learning to apply the distributive law to expand brackets. This is also known as eliminating brackets in an algebraic expression. I am successful when I can expand the brackets on simple expressions not requiring the collection of like terms, and expand the brackets for expressions that include negative numbers. So just a quick reminder about BODMAS or BIDMAS. We start off by doing brackets first in our order of operations, and then indices, and then division and multiplication at the same time from left to right, and lastly addition and subtraction from left to right. So the first thing that we usually do for BODMAS is whatever's inside the brackets. So order of operations is very important. So we will have to remember about that when we're doing this. Now, the distributive law is when we try to expand brackets. So that means we get rid of the brackets from a question. And the way we do this is whatever's out the front of that bracket, multiplying that bracket, we multiply that by everything inside the bracket. So for my example here, A is outside the bracket and B plus C is inside the bracket. And we expand this out by saying A times B and then A times C. And the same way can work for negatives as well. So if I've got A outside the front and I'm multiplying that into the bracket and there's a negative inside the bracket, that negative becomes part of that final equation as well. So in this case, we've got A multiplied by B minus C. And so we go A multiplied by B minus A multiplied by C. And I'll explain how that works a little bit later. Here's an example using area. So the area of this rectangle is A multiplied by B plus C. But we could work out the area by working out the first rectangle, A by B, working out the second rectangle, A times C, and then adding them together. And this is just a practical way of looking at how the distributive law works by using shapes. A good way to do this for the first couple of times is drawing those arrows in. It really does help to remember what I've done and what I've already filled out. So I'm going to give a couple of examples just using numbers first. So let's do 5 times 31. Now 31 we know is 30 plus 1. So we can rewrite this as 5 times 30 plus 1. So I can do the equation 5 times 30 plus 5 times 1. 5 times 30 is 150, 5 times 1 is 5, and then I add those together and I get 155. If you notice, my workings go down the page and those equal signs are all above each other to show each step of my thinking. So here's another one. This time we're doing subtraction. So 4 times 28. And you can see there 4 times 30 minus 2, because 30 minus 2 is 28. So I can do 4 times 30 plus 4 times minus 2. And this becomes 120 minus 8, which simplifies down to 112. So here's some worked examples. You can pause the video now to try attempting these and then come back and see the workings. And see if you've got them right. So let's start off with A. So on the left hand side I'm going to do my thinking, what's happening in my brain, and on my right hand side I'm writing down what I want my teacher or the person who's marking my test to see. That way they know that I understand what I'm doing here. So I will use the distributive law to multiply out that 3 outside of the 2x plus 5. So I'm going to go 3 times 2x plus 3 times 5. Now as mathematicians we could write in the multiplication symbol, but in some cases we just write in brackets to represent that this is one term and this is a different term, and we don't have to put that multiplication symbol in because we're efficient. We don't have to add those extra symbols in. So we work that out. 3 times 2x is 6x, 3 times 5 is 15, and we can't do anything with that. It doesn't simplify any smaller because they're not like terms. If you're not sure about like terms, click on the card up in the top corner to go back to about like terms in a previous video. So for question B, we're going to use the same type of thing, but this time we've got a negative out the front. So we have negative 8 times 7 plus 2y. So I'm going to use my distributive law. That negative 8 is going to times by the 7, and the negative 8 is also going to times by the 2y. And when we do that, negative 8 times negative 7 is negative 56, and negative 8 times 2y is negative 16y, and a plus and a minus, or plus and a negative, becomes just a minus. So that's a simplification. So our third worked example, we are going to expand out that 4x. Now we use that as a whole term. So we take that 4x and we multiply it by 2, and then we take that 4x and we multiply it by negative y, because that negative is part of that term. And we simplify that by going 4x times 2 is 8x, and then 4x times negative y is negative 4xy. And we can either leave it as plus negative 4xy, but because we're being efficient, that plus and negative counteract and it just becomes a minus. So here's some further examples which actually require some simplification using like terms afterwards. So again, I'm going to do my thinking and I'm going to do my working on the side. You can pause the video and try these yourself and come back for the answers. So using the distributive law, we only distribute over that first bracket. We're not going to touch that 3b at the moment. So that 3 is going to times by 2b and 3 is going to times by 5. You'll notice that I'd still have that 3b on that equation because an equal sign means that they're the same on both sides. So all I've done is I've expanded that bracket. Now I simplify down a little bit. So I get my 3 times 2b is 6b. My 3 times 5 is 15. And we've still got that 3b there. Now we can combine those like terms. We've got 6b and 3b. They can combine together, become 9b. And we've still got that plus 15 because that's not a like term to any of the b terms. Okay, for the second question here, we do the same type of thing. So we're going to expand those brackets, but in this case, we're only expanding that bracket with that second term, which is that 7x. That 12xy is not going to be used yet, so we're just going to leave it. We're going to copy it straight down, 12xy. We're going to have plus 7x times 2, and then plus 7x times negative y. And when we simplify this, we get 12xy, that stays the same, it hasn't changed, plus 14x, because 7x times 2 is 14x, and then 7x times negative y becomes negative 7xy. And again, we've got like terms there, we've got 12xy and negative 7xy. We can simplify them by combining them and becoming 5xy, because 12xy minus 7xy becomes 5xy. And then we've got that plus 14x just left there at the end. And again, we can't combine those any further because they're not like terms. Some reflection for this lesson. You should think about how multiplying numbers is the same as the distributive law when we're looking at algebra. And you can go back in the video and have a look at that. And also, can you see any patterns that we're forming with the different signs, with those things, with those equations? And second is, what patterns can you see with the signs? Go back and have a look at the positives and negatives and see how they propagated through to the final answer in our expressions. Okay, as always, like and subscribe so that you're up to date with the latest lessons that we are posting.